Welcome to Talk+Water, a podcast that takes a deep dive into the world of water with those making waves. My name is Todd Votteler, and I'm your host for Talk+Water. I'm also the editor-in-chief of Texas+Water and the Texas+Water Journal. You can sign up for Texas+Water by visiting Texas+Water.org. And you can sign up for the Texas+Water Journal by visiting TexasWaterJournal.org. Both publications are free. My guest today is Dr. Benjamin Cook. Ben is a research physical scientist with NASA's Goddard Institute for Space Studies. He's also an adjunct research scientist with the Lamont-Doherty Earth Observatory at Columbia University. His research focuses on three areas: the interactions and feedbacks between the land surface, terrestrial ecosystems, and the climate system, drought dynamics, and paleoclimate. Ben, welcome and thank you for being part of Talk+Water.
Oh, thanks for having me.
So let's start out with your background in water. How did you first become involved with water?
Really, it was from grad school. When I went to grad school to study basically climate change, I was trying to think of the area that I really wanted to focus on. And the one thing that really interested me was water, because that seemed to be the kind of space where climate change really hit people and ecosystems, kind of where they live. And so, my own kind of research developed from that interest in water and drought and understanding how all that is going to change in a warming world.
So tell us a little bit more about that research overall before we get into your new study.
Yeah. So, I studied drought very broadly from a lot of different perspectives. I studied droughts in North America that happened 1,000 years ago. I studied big historical events like the 1930s Dust Bowl drought or the 1950s drought in Texas. And then a lot of what I work on is trying to understand how climate change is going to affect drought severity and drought risk. How can we expect droughts in different regions of the world to change as the world warms over the next several decades to centuries?
So now you are one of the authors of a recent study that was published in Science with the title Large Contribution from Anthropogenic Warming to an Emerging North American Megadrought. Tell us about that study and its findings.
Yeah, so, that study kind of centers on two questions that we have. So, if you look at what's happening in Western North America right now, what you see is that most of the West, or a large part of the West, has been in more or less continuous drought for almost the last 2 decades. And so we were looking at this event and we really wanted to ask two questions. One, how does this almost 2-decade-long drought compare to the worst droughts of the last 1,000 years? All right. And then two, is there a climate change component there? Did climate change contribute to this event in some way? And so for this analysis, we combined a lot of data sets and expertise looking at tree ring-based reconstructions of drought over the last 1,000 years, instrumental records of climate and drought variability over the 20th century, and also climate model computer simulations of how we expect the climate to change, over the next 100 years. And we, from the study, we really came up with two really big, or what we thought really big results. One, this drought is really comparable to what are the so-called Megadroughts from 1,000 years ago. So if you go back 1,000 years ago, you see droughts that are 20, 30, 40, sometimes 50 years long, much longer than really even the worst drought events that we see in U.S. history, much worse than the Dust Bowl or the 1950s drought. And what we see is that this drought that's going on right now is really approaching the length and severity of those really extreme events, right? Which is pretty remarkable. So this drought is different than anything in the recent past. The second thing we determined too is that the reason that this drought was so severe and so impactful is that a large part of it is attributable to climate change. We estimated that about, depending on how you do the estimate, about 30 to almost 50% of this drought is attributable to climate change, which is huge, which means that, climate change turned what would have been a kind of normal run-of-the-mill moderate drought into one of the most severe events of the last millennium.
So now, while you're talking about climate change, that's where anthropogenic warming comes into play, right?
Yeah. So when we talk about climate change, we're talking about anthropogenic climate change. We're talking about global warming that's being driven by the burning of fossil fuels, primarily, that's putting up CO2 into the atmosphere, that's enhancing the greenhouse effect. And as that greenhouse effect gets enhanced, as the world starts to warm up, it changes patterns of weather and variability around the world. And in the Western US, it basically means just drier conditions.
So how do you identify the influence, the anthropogenic influence on the megadrought that you're talking about? How do you tease that out of the data?
Yeah. So, any event that happens today, right, is happening in a world with climate change. And so that means any event that's happening today is going to be some mix of just the natural variations of the climate system that would be happening even if people weren't here, plus some influence of climate change. And so what we can do is we can use different statistical techniques to kind of isolate what those factors would be, and then kind of recalculate what the drought would look like without climate change. So, for example, we know that with warmer temperatures, you get a greater what we call evaporative demand in the atmosphere, right? The atmosphere wants to suck more water out of the surface and make the surface drier. So we can estimate how long-term warming trends have influenced that, have increased that. And then we can take that and we can kind of subtract that off the current drought and the actual observations and use that as a way to kind of separate out, again, the natural variations and the climate change contribution. And a lot of this involves work with climate models, computer simulations that are designed to simulate all these processes. And these are models that make it very easy to kind of isolate and identify the climate change impact on very specific processes like evapotranspiration.
So the anthropogenic factors, they don't necessarily create the drought, but they make it more severe or maybe make it last long or something. Is that that's absolutely correct. Climate change is not going to, when they're talking about any extreme event, we're talking about droughts or floods, or heat waves. Climate change is not going to cause those events, but climate change can affect them. Climate change can make them more frequent, more likely to occur, more severe, more persistent. And so, it's the wrong question is, did climate change cause an event? The right question is, well, how much of an influence did climate change have? So we have the drought that's going on now, and I'm sure you're more familiar than I am with the research that came out in 2007 talking about how the Western United States was going to transition into more arid climate. I'm talking about a paper titled Model Projections of an Imminent Transition to a More Arid Climate in Southwestern North America. And that asserted that the Dust Bowl and the 50s drought would become kind of the new climatology for the Southwest in the 21st century. And do you see that has taken place?
Well, I think what it's showing is, a lot of the work that we've done in the past, both that paper and then some, work that I've done also with, other co-authors on the paper, is that if you look at the climate model projections for the future, the West looks drier, right? I mean, a warmer world means a drier West, means higher drought risk, means more severe droughts in the Western U.S. And that's the kind of aridification. This study shows that is already beginning to happen, right? So climate change is not just a future problem, but it's a problem ongoing right now. Now that said, natural variability is still going to be important, right? So even as climate change starts to steadily change the baseline, change the climatology to a drier one, superimposed over that baseline is just going to be natural variations, natural cycles of dryness and wetness. So, even in the future, we're still likely to get wet years or maybe even wet decades. But, what climate change means is that it's much easier to go into a drought, much harder to come out of a drought. And any droughts that do occur are likely to be much more severe than they would have been in a world without climate change.
So in my own research, I noticed 15, 20 years ago, looking at data having to do with recharge to the Edwards Aquifer in Texas, that it seemed like if you looked at the recharge going back to the 1930s, that starting in the late 80s, you saw this pattern where there were really much more exceptional dry years. And then there were even more significant flood years, following that. This pattern of, a few dry years put together more frequently and them being more severe, and then really big flood events ending that dry period. And, I could see this pattern that was emerging that you really didn't see in the earlier data. Is that the kind of thing that maybe we're going to be experiencing?
Yeah, I mean, it's possible. I mean, Texas is, even in the Western U.S., Texas is kind of exceptional from this perspective where, it oftentimes swings from these really extreme dry, drought periods, drought years to really extreme, wet years. And California is also kind of very, very similar that way. It's hard to say specifically if recent trends are, climate change or, indicating a trend, driven by climate change. You really need to do a kind of deep kind of analysis like we try to do with this paper before you can really say that with any confidence. But there is some evidence that, at least more broadly, we expect all the extremes to kind of increase. Global warming kind of supercharges the hydrologic cycle, meaning that when it's dry, it's even drier, and when it's wet, it's even wetter. And so it's a possibility, but it's hard to say anything kind of definitively about that thing right now.
So the study, I think, really drilled down on the Colorado River Basin. And I'm looking at that and I'm thinking, what are the implications of this new climatology on that basin?
Yeah, I mean, so, it's funny, water in the West is, obviously a contentious, complicated, kind of fraught issue, sensitive to a variety of social and cultural and physical factors going back 100 years, right? On one hand, I think there's reason to be relatively kind of optimistic in the sense that, what we've seen in the Western U.S. over the last 20 years is actually a lot of cooperation. People, states, stakeholders, managers kind of taking the initiative to come up with the best kind of compromise solutions to try to figure out, how can we keep making the water deliveries, even in the midst of, some of these extreme drought years. Now that said, well, let's also say we have a kind of toolbox of things that we can do to kind of deal with this stuff. And so the big question then becomes, is what we're doing now going to be sufficient to deal with, water in the future or water issues in the future? And maybe not. But again, we're not kind of just passive responders. We have agency, and there's a lot of things that we potentially could do. Right. I mean, there's discussions to be had about things like groundwater banking or decisions about agriculture, or revisiting some of the ways the water is distributed and stored, which doesn't mean that they don't present kind of challenges, but, we're not at a dead end. There's things we can do. It just, what matters is that people don't pretend this is not going to be a problem and it's not going to be an issue, because by all accounts, the best evidence we have is the West is going to get drier. people in the West are still going to need water. And so, let's maybe be proactive for once and try to figure out the best way to deal with that.
So I just want to say that I think you're absolutely correct about that. I see examples all over the Western United States where there are institutions coming together and stakeholders coming together to try to change the way they manage water and are seeing success in doing that. And so that gives me a lot of hope for the water side of the equation having to do with climate change, at least in the Western United States. When you look at indicators, though, one of the things that I'm interested in is snowpack. It seems like, that's a really obvious indicator for people to watch in terms of the influence of climate change on water supplies. And, even in Texas, we do, people don't really think about it too much, but we do have to watch snowpack because that is a contributor to water in the Rio Grande.
Yeah, in some ways, snowpack is kind of the canary in the coal mine of this sort of, of kind of climate change and water. And the reason for that is because, it responds very strongly to a threshold, right? Like if it gets above freezing, then snow melts, precipitation falls as rain rather than snow. And suddenly even if you're getting the same total amount of water inputs, you've fundamentally changed the seasonality, the hydrologic cycle in ways that oftentimes we're not prepared to deal with or manage around. And other studies have shown, you can see a clear climate change signal in both recent declines in the snowpack in the Western U.S., including in the Cascades and the Sierras over the last, 100 years, and is a clear climate change signal in some of the snow drought years that occurred during the worst of the California drought years. So particularly in kind of the warmer mountain regions at the kind of lower elevations, warming is likely to have a very strong kind of impact. In the case of the Colorado, there's still, a little bit of kind of discussion there about it. And part of the reason is that, the Colorado, river watershed is very high elevation, right? And a lot of the snow happens at very high elevations that even now are not being impacted so much so much with warming in the sense of, it's still not getting above freezing. So it's possible that, some of those areas could, serve as kind of refugia, places that might be a little bit more resilient in the face of climate change compared to, parts of the Cascades or the Sierra.
Of course, there are parts of the world, for example, the Himalayas, where those regions really depend on snowpack in terms of water supply and contributions to rivers. How do you think that those countries are going to fare? They're under the same kind of pressures, are they not? They're going to see reductions in snowpack, and they've got water that is already being contested by a number of nation states that share those rivers. What do you kind of see potentially happening in situations like that?
Yeah, I think a lot of these regions are going to have to deal with the same kind of struggles, and issues as water managers in the West, who all, many of which also are, managing water resources that depend critically on snow. What to do about it, is hard. Oftentimes, the problem is not that there's less water, but that the water is coming at the wrong time. So for example, in California, California's reservoirs are managed for flood control during the wintertime. So they basically try not to store too much water in the reservoir so that they can absorb kind of big storm events. They're depending on having that snowpack there that can store the water that then they can capture in April with the big snow melt and use that water in the summer and the growing season. So that's how do you kind of change your management structure around that? The West is going to have to figure that out. Other places of the world are going to have to figure that out as well. And a lot of other places too, you're going to have issues with transboundary water issues. So, I think a really good example is the Mekong, river system. The headwaters is snowmelt, fed, and that's entirely controlled by China. And so, working out those issues between China, making sure that there's cooperation between China and Southeast Asia to make sure that everybody's getting the water they need, can be a kind of contentious, thing. But, again, it's something that people are going to have to deal with and address.
So I want to go back a little bit and talk about tree rings and the information that you used to put this study together. And just thinking about that there are also, I guess, some other sources of potential information. I don't know if you use pack rat mittens or speleothems or anything like that, but I'm just curious, we've got, it looks like to me, a great wealth of tree ring data in the United States, which has been cataloged and is available. Is that really the situation all over the world, or are we just fortunate that we've been doing it and we have that at our fingertips?
Yeah, I mean, Western North America, and in this regard, Western North America is really lucky because we have lots of trees, many of which live a very long time, hundreds and even over 1,000 years. And these are also trees that are very sensitive to drought. And so, the advantage of trees is that, there's lots of them. They can tell you what's happening in an individual year. So you can get some very high resolution data, and you can get some really finely detailed picture of drought variability across space and time. Right. Now, within North America, if you want to go back further in time, beyond about 2,000 years, then, tree rings are going to struggle. We only have a few places where we have trees that go back further than that. And so that's where you're going to need to lean on some of these other, proxy records that you mentioned, like speleothems or pack rat mittens. There's a lot of other areas that have trees that can help us out. So, Europe and the Mediterranean, Asia, Russia, New Zealand, Tasmania are all places that we can get a pretty good handle on drought using tree rings. But then there's a lot of really important regions that we don't have the data, right? So a lot of the tropics, they have trees, but the trees don't put on annual rings. And so we can't really use them to look at past drought variability. Much of Africa, doesn't have a lot of trees. Or trees that we can use for this purpose. And so a lot of these other regions, you have to either do a lot more work to try to see what trees are available, or in many cases use, like you said, other proxy records to kind of fill in the gaps that, that we typically can't with using tree rings.
So the study has been out for a week or two now, at least. What's the reaction been thus far? How would you characterize that?
Yeah, I mean, there's been obviously a lot of interest, especially from, people who are not specifically within the kind of scientific community, which is good because this is what we were hoping. We were hoping this kind of, study, we felt it was important enough that we wanted, to engage people and communicate it to kind of a much broader audiences. And we feel like that's been accomplished. The reactions, are, oftentimes a lot of worry, right? I mean, people in the West, have been living through this drought in various kind of ways. And so, they're kind of intimately familiar with it. And, certainly nobody likes to hear that, these sorts of events, are the sort of things that climate change is making, much more likely. But most of all the people I've talked to kind of are really interested in and appreciative of the information and our work to try to understand, what climate change really means for water in the Western U.S.
Have you noticed any differences in the way people receive information when it's related to climate change over the last few years? Does it seem like maybe that there's a greater general recognition about it?
I think so. And I think a lot has been driven by, for lack of a better word, kind of the Greta effect, where, Greta Thunberg, along with a lot of other youth leaders, have really kickstarted a movement, to, really push forward this idea that climate change is a problem that we need to start dealing with. And, one of the beneficial side effects of that has been that there's been much less attention paid to, either by the media or even by politicians, to the kind of fringe climate deniers. And, so it's made it much easier to actually kind of communicate and get the message out and really discuss, climate change from a perspective of what people care about. I mean, the noise is much reduced. And so, so I think there's a better appreciation. I think the conversation has shifted at a large scale. I think the conversation has shifted from, is it happening, to what do we need to do about it, or what can we do about it, which, I think is heartening.
Do you see that people are optimistic or pessimistic about how they're going to try to deal with climate change, and how the government is approaching it?
Yeah, I don't know. It's hard to say. I mean, just because the approach is so fragmented, right? I mean, a lot of the work that's actually being done from a kind of adaptation perspective is really being driven by kind of local and state governments, and so they're kind of doing, a lot of them are doing what they can to kind of prepare for climate change, to plan for it, to work on adaptation measures, to try to figure out what they need to be concerned about, as they move forward with developments over the next kind of few decades. So I think that's, a kind of a source of optimism. There hasn't really been any leadership at the federal level on this, and even internationally, there's the Paris Agreement, but the Paris Agreement is it's probably not doing as much as it really should be, to really kind of rein this in. What I point out to people is right now, we've had about 1 degree of climate change, right? And we're already seeing significant impacts, around the world, sea level rise, floods, extreme storms, droughts, heat waves, kind of you name it, right? Our current trajectory is for another probably 2 degrees by the end of the 21st century. Right. So, triple everything that's happening or, now, and that's kind of where we're headed. And that's something that, we probably need to be a lot more aggressive about, at the kind of international scale.
So we're going to go ahead and wrap up, but I want to ask you if you could help us, for those who would like to learn more, where are some places that they might go to find out more about megadrought and climate change?
Oh, yeah. So carbonbrief.org is a great news site that has articles about drought, but also just great articles about the kind of current state of climate science and climate change. And it's a really great kind of approachable website to cut through a lot of the noise. Any of our websites, searching for, lead author Park Williams or myself, and you'll find, lots of links to, to articles and interviews and things we've done, all kind of talking about megadroughts.
So my last question for you is what's next for you?
Yeah, we're still kind of interested in the climate change and drought question, and a lot of it is trying to understand, what are the kind of range of possibilities, in the future, given different kind of trajectories, how, what's the best case and maybe worst case scenarios for climate change and drought, moving forward. And then also kind of to drill down a little bit more to think about kind of drought impacts, when you get a drought event, at different times of the year and different locations, what does it mean for water resources and ecosystems and agriculture and even people in those regions? And to try to, look a little bit more at this kind of specificity.
Ben, thank you so much. I've really learned a lot, and I know that our listeners are going to find this conversation today very interesting.
Okay, great. Happy to do it.
This has been Talk+Water. My guest today was Dr. Benjamin Cook, a research physical scientist with NASA's Goddard Institute for Space Studies and an adjunct research scientist with the Lamont-Doherty Earth Observatory at Columbia University. My name is Todd Votteler, the host of Talk+Water. Let's talk water again soon.